This is objective 1.6C, D. And our essential question today is, what formulas and strategies can I use to find the area of rectangles and triangles given vertices? Didn't quite have room there. So we're going to plot triangles and rectangles on the coordinate plane. Vertices are the endpoints that make the shape. If that's all I'm given, then how can I find the area of those shapes? So let's start with this word here, circumscribe. Circumscribe is to draw a geometric figure around another figure so as to only pass through the vertices of the inner figure. So like with most things, I give you the definition and then we'll go through and explain it. But that's what circumscribe is, to draw a figure around another figure so that we only touch the vertices for a triangle. So here would be an example of that. So here's a triangle, right? Oops. And then we draw this. Let's do it like this. There's my triangle. And then we draw a rectangle around it so that the rectangle is circumscribed around the triangle. Notice that it only touches the triangle at its vertices. So, just talk about some basic formulas, things we've been doing for a long time in math. Area is length times width. Remember that these are vertices right here, 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 and here. The formula for the area of a triangle is half the base times the height. Now remember that the base and the height come together to form a right angle. So for the right triangle it's pretty easy, but when you have a non-right triangle, to find the base and the height, I need to have it come together to make a right angle. We can also use the Pythagorean Theorem. We just got done going over that. A squared plus b squared equals c squared. Don't forget that c is always the side opposite the right angle, the hypotenuse. And these are legs. And of course the distance formula where D equals x2 minus x1 quantity squared plus y2 minus y1 quantity squared square root of the whole thing, where we go in and we draw a right triangle and we figure out that this is x2 minus x1 and this is y2 minus y1, and then I can find my C. Alright, so let's do some basic triangle area problems and one rectangle. So I've got a bunch of numbers in example A. The ones that I'm worried about are the base and the height. That means that I need to pay attention to this number and this number. So area equals half of 6.8 times 11.5. That's 3.4 times 11.5. That's 361 units, 0.61 units squared. So we say unit squared because I don't know if it's centimeters, inches, feet, whatever, but all area is squared. Feet squared, inches squared, etc. All right, so when we look at number 2, again, B, again, we've got a couple numbers, but I only am worried about the base and the height. The ones that I need to worry about is that this is the base and this is the height. I should label that over here. This is the base and this is the height. So the only ones that I'm concerned with are 8 and 11. So area equals half of 8 times 11. That's 4 times 11. That's 44 units squared. Again, making sure that we put units squared because it is an area measurement. One of the ways that they trip you up on tests is to put the same number, 44, and there would be units squared, and there would also just be units. All right, number 3, C. C is just a rectangle. So because it's a rectangle, I only have to worry about the length and the width. That's a cursive L, just because we use a little lowercase l to represent that. So area equals 15.2 times 12, which is 182.4 units squared. So basic area, you've been doing this for a long time, shouldn't be a big deal. What we're focused on is finding those measurements using either the distance formula or the Pythagorean theorem. So let's go look at some problems on the back. So now I have this big problem. Notice there are only 2 of them. That means your assignment should be similar. So I want to find the area of a rectangle, and I give you the vertices. So the first thing I'm going to do is label all that stuff. So N is 1, 7, O, -1, 5, P, 3, 1, and M, 5, 3. So now I have all my numbers, and then I have the steps spelled out for you. So we're going to use the Pythagorean theorem to find OP. Actually, I'm going to use the Pythagorean theorem or the distance formula, so I can use either one. So let's do the Pythagorean theorem first. So OP is right here. So, when we use the Pythagorean theorem, we draw a triangle, which gives us sides of 4 and 4. So to find OP, where O is -1, 5, and P is 3, 1, the first thing we're going to do is the Pythagorean theorem. So c squared equals 4 squared plus 4 squared. C squared equals 16 plus 16. C squared equals 32. So C equals the square root of 32. And we're going to leave them in ugly radical form until we get simplified. Or I can use the distance formula. So going back to my points, I'm going to label O x1, y1, and I'm going to label P x2, y2. So that I can say that I have 3 minus -1 squared plus 1 minus 5 squared. That's 4 squared plus 4 squared. That's 16 plus 16. That's the square root of 32. So, same answer, which is good, we should have. And you can see that it doesn't really matter which one we use. They're kind of the same. So now I have to find NO, where N is 1, 7, and O is, again, -1, 5. So using the Pythagorean theorem, c squared equals, gotta draw a triangle first. So here's a triangle where I have 2 and 2. So that's 2 squared plus 2 squared. C squared equals 4 plus 4. C squared equals 8. So C equals the square root of 8. So we're going to do the same thing using the distance formula. You get to choose. It doesn't matter which one you do. Whichever one you see first, whichever one you feel is easier, is what you get to do. So we're going to label, this is x1, y1, x2, y2. So I have -1 minus 1 squared plus 5 minus 7 squared. That's -2 squared plus -2 squared. Notice that I keep putting the square root over each piece. Don't leave that off, and just because then you'll forget to do it. So this is the square root of 4 plus 4, which is the square root of 8. Okay. All I've done so far is find this length and this length. Now I have to find the area. So now I know that area equals length times width. That's the square root of 32 times the square root of 8. So I have 16 units squared. Remember, our calculators do this ugly math, so you don't have to simplify this. If when you're doing it, you could get, let's see, that's 2 square root of 2 for the square root of 13. You might have gotten, like on your calculator, you might have gotten 2 square root of 2 here. And this is also 2 square root of 2. So it's okay. Then you would just plug that in right here, and it would be fine. This could also be 2 square root of 2 times 2 square root of 2. Is that right? It's 4 times 2, square root of 2 is 2. Yep. That's 16 times 2. The square root of 16 is 4. Nope, this is 4 times 16. This is 4 square root of 2. That's what I get for hurrying through my math. So you could do that, and it would still give you 16. So just be aware that if you use the calculator and it simplifies this for you, that's okay. Just go with it. You're still going to multiply it out. So over here in our triangle, just to be all the way effective and proficient, this is square root of 8, and this side is the square root of 32. And then we do length times width. See? Not hard. Many steps, none of which are difficult. So now we're going to do a triangle. And this time, I don't have a base and a height. So first we're going to circumscribe a rectangle around the triangle. So there's our rectangle around our triangle. Then we're going to find the length and width of the rectangle. And then we're going to look at the 3 little triangles that are around it. So if you look here, there's a triangle here. I don't want to do that. There's a triangle here. I know it's messy. It's kind of messy on purpose so that we can see the triangles that we're looking at. So there are these 3 little triangles. And what we're going to do is find the area of the rectangle, subtract all the colored ones out, and that's going to leave us with our original highlighted shape. Okay? So let's do some counting. First, we start with the idea that the rectangle is 3 by 5. So the area of the rectangle is 3 by 5. And then we're going to start subtracting triangles. So first we're going to subtract the pink one. And the pink one is 3 by 1, 2, 3 by 4. So area of triangle 1, so we'll call this triangle 1, is half of 3 times 4. And then we'll do the green one. So we'll call this triangle 2, and this is 1 by 2. So I'm going to subtract the area of triangle 2. That's half of 1 times 2. And then we'll do the red one again, and that is area of triangle 3. And that's 1 by 1, 2, 3, 4, 5. Half of 1 by 5. That's going to give me the area of triangle KLM, the inside piece, the highlighted part. Okay? So, math time. So, 15 minus 6 minus 1 minus 2.5 equals 5.5 units squared. So again, for your summary, look at the steps that we did. There are 3 steps here. This is for a rectangle. Talk about how we had to draw 2 small triangles, and then once we had those lengths either way by the Pythagorean Theorem or the distance formula, and then we found the area. Or look at these steps and make sure that you can summarize how to find the area of a triangle after it is circumscribed.